The MEDOLICO Project aims to prevent and reduce the environmental impact of wastewater produced during the olive oil production. Olive mill wastewater, OMW. The main problems associated with the OMW are mainly related to its cytotoxic character due to the presence of phenolic compounds, which cannot be degraded by biological treatment. Adverse effects on soil properties and phytotoxicity towards various plants have been reported to occur when this waste is used directly as an organic fertilizer. Currently, the major part of the olive mills in the Mediterranean area, representing 90% of the global production of olive oil, use potentially harmful and less efficient treatment methods of OMW, with evaporation ponds or land spreading of OMW being the most widely applied approaches along the Mediterranean basin. The project is being carried out by a partnership composed by entities coming from 5 Mediterranean countries highly active in the olive oil production: Cyprus, Israel, Italy, Jordan, Portugal. These partners are committed to the identification of suitable treatment technologies for reducing the environmental impact and improving the sustainability of olive mills. The project has focused on the evaluation of the performances of 3 advanced treatment processes aimed at properly managing OMW. Solar-driven advanced chemical oxidation known as solar fenton combined with coagulation, flocculation pretreatment. Intensive aerobic biological treatment through the application of a Jacto reactor. Integrated membrane filtration and separation processes. Microfiltration followed by reverse osmosis and microfiltration followed by nanofiltration. These processes should be simple and cost-effective to allow olive millers to adopt them in a compatible with the strictest environmental standards way, therefore hindering any risk to the surrounding environment. Efficient. To minimize OMW polluting load, improving thus the sustainability of olive mills. Environmentally friendly. To minimize the polluting load of OMW and enhance its safe reuse potential for irrigation. Forerunner of new opportunities in terms of enhancement and valorization of the high added value products of the olive oil production cycle. Purification of olive mill wastewater through the utilization of a solar compound parabolic collector pilot plant. Objective: to reduce the olive mill wastewater environmental impact by means of a sustainable process. How? Stage 1. OMW coagulation, flocculation, pretreatment with chemical agents. To reduce the solid fraction of OMW prior to solar fenton. Stage 2. OMW oxidation by means of solar fenton oxidation process. The fenton reagent refers to a mixture of hydrogen peroxide and ferrous salts in acidic medium, and its high efficiency is attributed to the generation of very reactive hydroxyl radicals. Solar fenton oxidation combined with coagulation, flocculation pretreatment may constitute a potential solution for the purification of OMW, resulting in considerable organic load removal. The polyphenolic fraction can be eliminated by the chemical oxidation process, while solar fenton seems to be capable of achieving a reduction of the OMW final toxicity, reinforcing thus the concept of sustainable wastewater reuse. Intensive aerobic biological treatment in Jacto reactors with ultrafiltration membrane unit. Objective: to decrease the OMW polluting capacity through an intensive biological aerobic process. How? OMW enters the reactor and is treated with aerobic microorganisms which purify them. Resulting water can be used for irrigation. OMW integrated membrane process, microfiltration, reverse osmosis. Objective: to recover water to be reused for various purposes and to extract polyphenols out of OMW. How? Phase 1. OMW is microfiltered to remove suspended solid components. Phase 2. The resulting water is treated with reverse osmosis to get it desalinated and free of organic components. With this technology, the purified water can be reused in the olive oil production cycle and for irrigation. The resulting water is clear, colorless, and has a low salinity. Furthermore, a small amount of water rich in polyphenols is also obtained from this process. OMW membrane treatment, ultrafiltration, nanofiltration, followed by recovery of polyphenols with a membrane contactor, MARS. Objective: to extract valuable components, polyphenols, and to reduce environmental impact of OMW. How? Stage 1. OMW is treated with ultrafiltration and nanofiltration. Stage 2. A smaller volume of water is obtained, which is rich in polyphenols, and is treated with a MARS process aimed at extracting the polyphenols. The MARS extraction process is based on the use of membrane, which are very selective and allow the passage of only some polyphenols. By treating the OMW through these processes, their environmental impact is reduced and polyphenols are extracted. The exploitation of polyphenols will open new market opportunities. Main results obtained by using these technologies are: 1. OMW impact reduction. 2. Production of purified water for various purposes such as A. Reuse in the production cycle. B. Irrigation. 3. Recovery and valorization of polyphenols for application to the pharmaceutical industry, the cosmetic industry, the nutraceutical industry, the production of animal feeds. MEDOLICO Project's partners provided various technological solutions for the treatment and proper management of OMW. The project results will allow olive millers to apply an alternative, cost-effective, and environmentally friendly technology based on their own situation. For example, capacity of olive mill, annual production of OMW, etc. For the OMW purification and recovery valorization of byproducts. The reuse potential of the treated OMW, for example, for irrigation, is expected to have a significant added value since these countries, as many as others in the region, have to face consequent years of drought and increasing water scarcity. Providing the olive millers with environmental and cost-effective solutions for the OMW management will make their business and their production processes more sustainable in the future, promoting thus the concept of circular economy.